Okay, good evening. So far, we have seen about introduction to cement. Then we have seen different types of cement. Before that, we have seen how the cement is being manufactured. Then later on, we have seen what are the types, which is types of test which is available on the cement. So we have seen about field-based tests as well as laboratory-based tests. So in the case of field-based test, how you have to evaluate the procedures I have also given. And in addition to that, we have seen about few laboratory-based tests such as initial setting time, sieve test, fineness test, final setting time test, standard consistency, then strength test, in soundness test, and so on. Now we are moving towards the next part, that is aggregates. So aggregates plays a major role in concrete. Why? Because 60 to 80 percentage of the volume will be, sorry, 70 to 80 percentage of the volume will be occupied by the aggregates only. So the aggregates provides the body to the concrete and reduces the shrinkage as well as stability. So earlier aggregates were considered to be chemically inert, which does not have any reaction with the cement paste. So, but nowadays, what happens due to the presence of artificial aggregates, these aggregates tends to react with the cement paste and tends to alter the mechanical properties of the concrete. So, they are called as chemically active aggregates. So, which have positive as well as negative impacts on the mechanical as well as durability properties of the concrete. Let us see one by one in detail. So classification of aggregates. First, we have three basic classifications based on the weights. That is nothing but the density. So lightweight aggregates, normal weight aggregates, and heavyweight aggregates. Lightweight aggregates has a density range between 300 to 1500 kg per cubic meter. So the best examples of lightweight aggregates are clay, shale, pumice, perlite. So this type of aggregates are used for the construction of lightweight concrete blocks. The best example is your AAC, autoclaved aerated autoclaved concrete blocks. And next type of aggregates we call it as normal weight aggregates. So which has a density between 1500 to 1700 kg per cubic meter. The best example is sand, crushed stones, aggregates, granite stones, and so on. These are all commonly used construction material which can used for the production of conventional type of concretes. And the last one is heavyweight aggregates which had a densities greater than 1700 to 3500 kg per meter cube. The examples are barite, magnetite, serpentine. So these types of rocks, these types of materials are used for the construction of heavyweight concrete. This concrete have been used for the nuclear storages, nuclear wastes, the nuclear weapons, and in the nuclear power plants, atomic power plants, and also. So the main purpose, it tends to retard the uh, harmful rays which is coming from uh, the nuclear reactors. So for that purpose, this type of aggregates has been used for the construction of nuclear storage yards. So apart from that, we have two basic classification, natural and artificial aggregates, as I said previously. So natural aggregate does not react with cement paste, first of all. In the case of artificial aggregates, some cases the artificial aggregates tends to react, but in some cases it does not react. So that based on that, how it is being manufactured. So the examples of natural aggregates are sand, stones, crushed stones, etc. So in the case of artificial aggregates, the concrete aggregates, that is recycled concrete aggregates, sintered aggregates, copper slags, and other industrial byproducts. Concrete aggregates, in the sense, after the surface life completed building, the concrete was demolished and it is crushed and it is processed to make the aggregates. That type of aggregates we call it as concrete aggregates. Sintered aggregates means the loose powders will be compressed at a high temperature, forming a solid mass. That type of aggregate we call it sintered aggregates. Copper slag, it is one of the byproduct from the copper manufacturing unit. Similar like your GGPS. So during your steel production process, slag will be coming out, that will be called as steel ground granulated blast furnace slag. In the case of copper production unit, so some amount of glass slags will be coming out, that we call it as copper slag. But the density range between the steel slag and the copper slag is quite different. And next is based on source. Source of aggregate, we have two types of aggregates. First is natural rocks. Second one is industries. Let us see one by one in detail. Natural rocks, we have three types of natural rocks on Earth. First one is igneous rocks. Second one is sedimentary rocks. Third one is metamorphic rocks. Igneous rocks are formed with the help of molten magma or lava, which is coming from the Earth's core to the Earth's surface. Generally, these types of rocks will be seen in the areas which have higher number of volcanoes. So second is sedimentary rocks. Sedimentary rocks are formed by deposition of other materials. So it will be in the case of ocean-based or sea-based things, sediments will be deposited layer by layer. So each sediment will be deposited over the another sediments. So as the days pass by, due to the temperature and pressure, the rocks will be created. The types of rocks will be called as sedimentary rocks. And lastly, we call it as metamorphic rocks. So these are generally basically from the igneous or sedimentary types of rocks. Due to high pressure or metamorphicity, due to extreme heat and pressure, these types of rocks are being formed. And these types of rocks being distributed throughout the Earth's crust based on the geological formation of the parent rocks. So mainly in the concrete production process, in the case of southern parts, say for example, in the case of India, people will be using crushed granite chips as the coarse aggregate for the production of concrete. The main reason is it does not react with any other materials. It is an inert material. It is quite stronger when compared to all other material. That is the reason why crushed granite stones or chips are being used for the construction of structures. And the next is aggregates from industries. So the main why we have to use aggregates from the industries, the main reason is to reduce the environmental pollution. So generally industries will produce large amount of byproducts which are being not used properly, and it is being deposited in the open barren land. So in depositing in the open land, if it is used for some useful products, so that the environmental degradation can be reduced. So for protecting the environment and to reduce the environmental pollution, these aggregates, these industrial based aggregates have been used in the construction sectors. And this image represents the use of industrial byproducts. The topmost left corner shows the building. After service life of the building, it will be demolished. So it will be called as construction and demolition waste. After which it will be processed to make into form of a small aggregates. See, it is in the right bottom corner of the presentation. So you can able to see the large boulders was converted into small aggregate sizes ranging between 12 to 20 mm. So this can be utilized as a replacement for conventional coarse aggregate, so that we don't need to depend on natural materials. So artificial materials can use it to produce the concrete. Then here in the left bottom corner, you can able to see some molten material is being dumped in open land. This is nothing but the copper slag. After the production of copper, some amount of debris is being left. That debris will be collected and it will be poured in the open land. So after hardening, it will be looking like a some large chunks or else large chunks. So after this, the large chunks will be crushed using a crushing unit. Then it will be converted in the form of different sizes of aggregates. Say for example 4.75 aggregate, 12.5 mm aggregate and 9.5 mm aggregates. So these aggregates are being utilized for the construction purposes, which are used to replace the natural aggregates so that the natural materials can be saved. So here sintering process has been shown. This is the sintered aggregate, sintered lightweight aggregate. The best example is LECA. LECA is nothing but expanded clay aggregate, lightweight expanded clay aggregate. So this type of aggregates are mainly used for the production of lightweight concrete, as it's shown in the left top corner. So we have different shapes of aggregates. So first of all, we have seen about the origin of aggregates, and we have seen what are the classifications of aggregates. Now I'm going to represent the shapes of aggregates. So we have mainly three main shapes. First one is rounded shapes, which has a smooth feeling, and another one is flanky aggregates. So one dimension of the aggregate is being lengthened. And another one is crushed aggregates. Here it does not have a smooth surface, rather it has a rough structure. So in the construction purposes, we have to use crushed aggregates. Why? Because If the aggregates are being smooth, it does not get good bond between the cement paste. So instead, we have to use this angular shaped or crushed aggregates so that the bonding between the this rough texture will be good, so that the load carrying capacity of the concrete will be higher. So in the right bottom, you can able to see the size ranges as well as three shapes, that is round, irregular, and angular. So 40 mm, 20 mm, 10 mm, and 4.75 mm different sizes of aggregates are there. So in round itself, we have different ranges, and irregular shapes also we have different ranges, and angular also we have different ranges. And we have similar to the cement testing procedure, we have some different tests on aggregates to check whether it's suitability for the concreting, the construction purpose or not. So different types of tests are available. First one is aggregate crushing test. Second is aggregate impact test. Then aggregate abrasion test. Then flankiness index test. Then elongation index test. Angularity test. Soundness test. Specific gravity and water absorption test. And stripping value test are available. So aggregate crushing is nothing but, so some proportion of aggregate will be taken and it will be crushed in a crushing machine. So after crushing, using 2.36 mm sieve, you have to sieve it and you have to check how much amount is being residue on the sieve. So based on that, aggregate crushing strength will be evaluated. Similarly, impact testing machine is available to check the impact strength of the aggregates. Then aggregate abrasion, in the sense, using a larger drum, we'll use some 9 to 10 numbers of steel balls, and these steel balls and aggregates will be poured in a steel drum, and it will be closed, and it is allowed to go for some revolutions. So during the revolution, this aggregates and the steel balls tends to collide each other. So based on the collision, uh, how the aggregates are being powdered is evaluated. Based on that, the abrasion rate of the aggregate is estimated. So in the case of flankiness and elongation, we have rulers and scales to find the how much portion of the aggregate is being elongated or flankinized. Then angularity test is also available. And soundness test is also available. Soundness test is how the aggregate is inert in nature, and specific gravity represents the density of aggregates. Sorry, specific gravity and density represents the natural property of aggregates, and water absorption represents the how much amount of water is being absorbed by the aggregates. Finally, stripping value of aggregate test is also being used. So basically, this type of stripping test is used to check whether this type of aggregates is being used for the road construction purposes or not. So initially, a layer of tar or bitumen is applied on the aggregate surface, and it will be boiled and it is dried. Again, it is boiled, it is dried. So continuous boiling and continuous wetting and drying will be taking place. And during that time, how much amount of bitumen is peeling, we have to estimate. Based on that, stripping value of the aggregate will be found. Okay, thank you.